if we have only 14 students so far, so hopefully more are joining in pretty soon. So we'll give them a few minutes and then we'll get started. Okay, as people are joining in, one of the major concern I have is I sent out an email today about the people who have not given me a proposal. So, has anybody got that email? Has anybody have a problem? Okay, if you got an email from me, there are several questions. There are several questions regarding that. There is several questions regarding that. If you got an email, I have not received your proposal. So I have only received 3 proposals from 3 groups. And those 3 groups I sent today my comments on the proposal. So if you did not get a comment on my proposal today, I never received it. So just make sure that tonight you forward. If you think you forwarded it and I missed it, I don't think so. But I don't know. Stranger things have happened. Maybe a spam filter got it or whatever. Okay. Some people are claiming they're sending me from Desire to Learn. I'm not receiving any email from Desire to Learn. I don't know why. So send an email to the email written by Mr. Labus. And as I said, I have only received from 3 groups. And those are the 3 groups I sent today my comments on the project. So if you are not those 3 groups, so that's probably half of the, as I said, those 3 groups constituted around 11 or 12 people. So other people, or maybe 13 or so, I don't remember. But if you did not get a comment back from me, that's because I did not receive your, well, I don't know. If you're sending it D2L and it's not coming to me, I don't know what to do. I have not received it. So only thing you can do is send it through something else to my email. I am not sure D2L I'm telling you that I'm not getting it. So there is really nothing I can say more than what you're supposed to do. But G2L should be working. If when you're sending an email, it's telling you that it is sending me to my email address. I okay. I'm not. Okay, I'm not going to repeat it again, but don't know why. Can't say why I didn't receive it. But if you're using the same thing, I got it from 3 other groups. So obviously, I can say what you are doing. I cannot predict that. I do not know what it is. So there's no point wasting time on arguing. As long as you can send it out today, I can check before the class is over and let you know that I received it, or I will send it out tomorrow. As soon as I get it, I will send it. Okay. So, there was one question from somebody that said that again, I see people joining in. I really do not like people coming to the class late, especially online. It is just not acceptable. So if I see a pattern, somebody coming in every time late, it will certainly affect your grade. So don't blame me at the end of the class, because I really do not like. I want everybody to be in the room like me at 7:40. If you cannot be here at 7:40, you better send me an email saying that you will not be here at 7:40. But something showing up at 7:48 is disruptive to the class, and I do not like it when I'm teaching that class in a physical location. I don't like it even more when it is online, because there is no traffic, there is no excuse to be late to an online class. You all know who you are, but I will encourage you strongly to be on class on time. Okay, so 2 things we're going to do today. We're going to go through chapter 3, the normalization, relational model, and normalization. I will look through my email and make sure I got the proposal from the 3 groups that I didn't get. Then we're going to have the quiz. On the quiz, we are at, I'm thinking depending upon where we go, somewhere between 9:15 to 9:30, we'll start the quiz. The quiz should take approximately 30 minutes. I will email you the quiz at that time. Once you finish the quiz, you can upload it to the quiz 1 folder in the Dropbox. Anybody has a problem following it? Do you know how to upload the quiz to the Dropbox? If anybody doesn't know, let me know. We will go through this material, chapter 3, as much as we can. Then we will, as I said, we'll go through the material till 9:15 or so, and then I will send you the quiz, and you can upload the quiz. I think I have set up so that you can only upload by latest by 10 o'clock. If you have any problem uploading, somebody says, yes, desire to learn. On desire to learn, there is a Dropbox, and you see a folder called quiz 1, and you should be able to upload it. If you have any problem uploading, then just email it to me. But I would like you to upload, and if you have problem today, tomorrow figure out how to. We really can spend now how to teach you how to use desire to learn. Call the help desk. It should be self-explanatory, but if you, I understand if you are the first time using it and you have a problem with it, just email it to me before the time is up, which I'll tell you at the If we start at 9:15, it should be 9:45. If we start at 9:30, it will be 10. So I'll just tell you, as long as I get it in the time frame, will be cool. Okay. So we don't go to quizzes. I don't understand what the review means. Maria says, so we don't go to quizzes. No, it's not going to be a quiz. I'll email you the questions. You will answer it. You download it to your laptop or whatever. Write your answers. Upload the document to quiz one in Desire to Learn under Dropbox. Okay. Yes, I know there is a quiz option on Desire to Learn, but I'm not using it. Okay. So in the last class we talked a lot about, and we did a lot of questions or exercises on SQL. One thing we have not talked about was the join, which I will cover today. Let's go this. I will talk about join a little bit because that's something we didn't cover. I was planning to cover later in the class in the semester, but I will cover it today, maybe after the break. So maybe we'll go through this till break, and it come back because we will cover the join concept in SQL, and then we will go to the quiz. And as I said, okay, the objective of this chapter is to understand the basic relational terminology. All the things that we talked about in SQL is basically relational database. So once we kind of said how the SQL engine works, we are going to talk about what is the building block of SQL. What is the building block of a relational database, and how relational database came into existence, and how do we design databases so that it's efficient, the information can be stored, or the data can be stored efficiently and can be retrieved efficiently. So in this chapter, we'll be talking about the basic relational terminology to understand the characteristics of relations, to understand alternative terminology used in describing the relational model, to be able to identify functional dependencies, determinants, dependent attributes, to identify primary, candidate, composite keys, to be able to identify possible insertion, deletion, and update anomalies in a relation. So we'll be talking about lots of things in this class, and we'll be talking about BCNF normal form. We're talking about the multi-value dependency, fourth normal form, all kinds of stuff. And I think in this chapter we'll also be, I think in the next class we'll be referring to the other book that I talked about. But I'll have some slides so that you can follow it. Okay, so the central premise. We have received one or more tables of existing data. The data is to be stored in a new database. Should the data be stored as received, or should it be transformed for storage? So you can basically think of it in terms of that you have this, you are designing a database based upon some data that you have received. How do you design the database? Like the example we took with the SQL, we have order item tables, two data, two items. So if somebody gets us in a real life, we go to a place and they say, we have this existing system where we are storing data like this. Should we store the two tables as they are? Should we combine them into one table? Should we break them up? Should we combine them? What should we do? And I think one of the things in your project proposal But I think that's the reason, I'm not too strict about refining them, because I think you guys have the concept, but I think some of you have one big honking table. Should we store everything in one table? Why do people break up data into different tables instead of storing everything in one table? So we'll be talking about some of the concepts, how to break data into different tables. So do we break data into different tables? What is the optimal, and what is the techniques we use to get there? So to understand all that, so when you get some data from somebody and you are designing a database to store those information, what is the best way to do it? To do that, we understand the basic terminology and the basic algebra that defines the relational database. The relational database and relational model terminology. So we will be talking about what is the relational model and what are the terminology we used. Prior to 1970s, I think as some of you or most of you know, all the computers used to be mainframe-like. Computers that were dedicated to do particular tasks, and they really didn't understand relational databases. For them, everything was a flat file. I think if you create an ASCII file, if you create an Excel spreadsheet, those are the examples of non-relational databases. So in 1970s, IBM, especially since IBM was one of the pioneers of mainframe computing, they were looking at how to better utilize and store and retrieve data without storing them in flat files, where a lot of replication and duplication of data is necessary. So E.F. Ford, he defined something called a relational algebra, and most commercial DBMS products now use relational algebra or relational model as the basis for designing relational databases like SQL Server. So what are the important terms? I think these are like the terms you should all know. What exactly are those? And those are the key terms in a relational model. Entity, relation, functional dependency, determinant, candidate key, composite key. Again, we'll go through each of them in detail, but we must know that these are very these are very critical terms when relational database model is concerned. So let's go through each of them. Determinant, candidate key, composite key, primary key, surrogate key, foreign key, referential integrity, normal format dependency. All these, you must know what they mean and what they mean in terms of relational algebra. An entity is something identifiable thing that users want to track. Customers, computer, stats. And I think one of the things that I think, without naming the group, I'm just going to talk about them, that somebody said that they want to track sales of iPad, of iPhones or Apple products. So if you're tracking Apple products, sales of Apple products, then you should track the product information, the customer information, the delivery information, the shipping information, the software that goes in all the components that the product contains, the manufacturers that the product, all this product. So we talked about the manufacturer, we talked about the shipping. So those are like 5 or 6 or 7 or 8 entities. So let's talk about a car rental system. A car rental system might have information about the rental. It might have information about the car. It might have information about rates for different times of the day. It might have information about billing. It might have information about insurance carriers. It might have information about employees who work in this car rental. It might have information about payroll, benefits about the employees who work inside the car rental property. It might have a database of locations that the car rental is located in. So you already can find out that there are dozens, there are literally dozens of entities that a simple thing like car rental reservation system or car reservation system.
Professor?
So when you're thinking of your projects, think in terms of entities, think in terms of things that you're trying to do. So we are in this class, which is the second level of database management. But we are not doing one thing. So any project that you have must track between 8 to 10 different entities. So don't think, like I'm saying you, in terms of car rental, I gave you an example of 10 or different things. Similarly, let's talk about a human resources system. A human resources system should have employees, it should have benefits, it should have HR, it should have, benefits might be broken down into healthcare, 401k, long-term disability, short-term disability, the providers that are providing long-term and short-term disability, the provider information. There might be a time entry system, there might be a vacation tracking of sick days and benefits system. There might be a expertise information who can do what. There might be information related to disciplinary actions that have been taken on particular employees, a system that tracks of that. So those are the kind of things. So there are, even on a HR system, you find out dozens of entities, or even a small system that we're going to develop, at least you can find 8 to 10 entities. So for the projects, minimum is 8 to so an entity is some identifiable thing that the users want to track. Customers, computers, cells, those are all entities. Relations. Electron DBMS products store data about entities and relations, which are special type of tables. So, I think a relation is a two-dimensional table that has the following characteristics. Rows contain data about the entity. Columns contain data about the entity. All entities in a column are of the same kind. Each column has a unique name. Cells of the table hold a single value. The order of the column is unimportant. The order of the row is unimportant. No two rows can be identical. Okay, a relation is a two-dimensional table that has following. Relational database products store data about entities. So let's talk about the customer entity. Customer entity is stored in a relation, then it's called customer. The customer is a two-dimensional table that has the following characteristics. It contains something about customer. So we can say customer billing information. It's a row about customer billing. Column data attributes. Column contains data about attributes of the entity. What does that mean? That means if you have a customer billing information and you say the attribute is customer name, column contains John Smith, and that's the name of the attribute. That is the data stored for the attribute of the entity. all entities in the column are of same kind. All entries in the column are of same kind. That means you can only store data that is of a similar kind. You cannot make alphabets and numerics and stuff like that. Each column has a unique name. You cannot have two columns in a relation which are the same name. Cells of single table hold a single value. The order of the column is unimportant. The order of the rows is unimportant. Okay. So let's look at an example and this. In this, the relationship is the employee number, first name, last name, department, email, and phone. Those are column names. Column jj@comword.com is a value for email. Okay. This is the column. This is a column. This is a row. So two rows cannot be the same. In a relational database, you cannot store the same information twice. You can only store it. So two, if you look at it, these are called rows. 100 Jerry Johnson, this is a row. This is a row. This is a row. This is a row. This is a column. 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 Two columns cannot be the same name. You cannot have two employee numbers. You cannot have two first names. You cannot have two last names. You cannot have two departments. Similarly, you cannot have two rows which are exactly the same. If you look at it, the two rows, nothing is exactly the same. The order of the columns is not important. If we change, we move employee number after first name and last name, it's the same relation doesn't change. Similarly, the order of the rows doesn't matter. We can display 100, then 300, then 200. Okay, let's look at it.
What a mess.
Okay. Okay. Does everybody gets does anybody have a okay, anybody has a problem understanding what I'm saying? Okay, I'm hearing some people are having problem hearing me. Who is having? Let me so that I can count it. How many of you are having problem? Just let me know right now. Okay, I have 1, 2, 3 people who said they have a problem. Is that all? Anybody else having a problem? I will, since there are 20 plus right now, I will encourage those 3 people to call the 800 number that's written. Those people are very good. I called them a couple of times. They answered the phone in less than a couple of minutes. I will encourage you to call them right now and see what the problem is. Because as I said, I really cannot solve why you can hear if 17 out of the 20 people can hear and uh, 3 cannot hear. Okay, Maria, can you go ahead? You have a question? Let's see. Is it any better? Is sound any better? Rick?
Professor, can you hear us right now? Can you hear me?
Rick Harkness? Is sound any better? Ekta? Who cannot see the slides? That should be. So you cannot see them when I go full screen. Do you see it right now? So maybe we should just go with the small screen. Can you see it now? Because I have it in small screen. Okay, these slides are posted on D2L, I think. Have you guys downloaded it? Okay. Okay, this is, I can understand why it is frustrating for you guys, but it's also very frustrating for me because I really cannot solve every technical problem. I really don't have the time because I told you in the beginning of the class that it is beyond me to solve every person's home computer and why they are not unable to see. The only solution to this problem is to call the 800 number that is in the email and it's posted on D2L and see if you cannot hear. There are 3 people who can hear. I really cannot do anything about that. I'm not a tech support person for Blackboard, so I can't do anything. Okay, so now you are seeing the slide. So we'll go through. Let me see if I can load it. Okay. Now we'll just go through here and make sure everybody sees the slide. Let's do something different so that everybody can see the slide. Let's try this, see if this is better. This is very frustrating. What I'm doing is trying to load the slides. I tried the application sharing, and you guys saying that when I go to the full screen mode, you don't see it. So let's try the loading the content, see if that's better. Please select start saying or switch modes. Can you guys see now? Can everybody see the PowerPoints now? We'll do it this way because this other one is not working. Yeah, there's a window within a window, but I really can't do anything. This should be good enough. It's okay. I think we'll go with this because this looks like the best solution we have got. You have also it on Desire to Learn, so you can download it and see it yourself. So when I'm going to have any more discussion on this, you have two ways to get it. You can get it and you follow it as I'm talking. It's very easy to. I can tell you what slides I'm on, if that the other one is not working, so this is the only way we can get to it. Anybody who the three people who can't listen can hear need to call the 800 number to see what your problem is and get it resolved. Okay, so tables that are not relations, multiple entries per cell. You cannot have multiple entries the way it's shown right here. 400 Tom, first name, last name, accounting, email, and if the person has 4 phone numbers, relational model is not the right way. You cannot store more than one information in that column. And that's a distinction which basically says multiple columns per cell is not allowed in a relation or a table or a relational database. A relation with values of heading length. We cannot have a relation. Here is an example of where you can have a comment which is really long or really small, and a relation will allow you to store that kind of information. So you can have a comment which is really long, but cannot have multiple comments listed in a relationship. And that's the difference, that you can have multiple comments, but you will not have, you cannot have multiple comments, but you can have a long comment. Okay, so this is important, and I think we will use in this class. Although not all tables are relations, the term table and relations are normally used interchangeably. The following set of terms are equivalent. Table and relationship, they are synonymous. We use table and relation. Anytime you are unable to see the slide, let me know immediately, so that I know. Last time I heard after 15 minutes that you are unable to see the slides. So if you are unable to see the slides, let me know as soon as possible, so that I will fix it. Table and relation are synonymous. In this class, we will be using table more often than relationship. Column and attributes are equivalent, but we will be using a column mostly. Row and tuple are equivalent, so, and we will be using row, not tuple. But those are the terminology, so we'll be using row, table, and column, which are same as relation, attribute, tuple, pipe, file, field, and record. Okay, so now we come to the fun thing. A functional dependency occurs when the value of one set of attributes determine the value of second set of attributes. So in a student table, we have student ID, student name, let's say the dorm they're living, the dorm name, dorm room, and fee. So student ID determines student name. Based upon the student ID, also determines which dorm the student lives, which room the student lives, and what fee, because a dorm, a room has a particular fee associated with it. The attribute on the left-hand side of the functional dependency is called a determinant. Functional dependencies may be based on equations. Extended price equal to quantity into multiplied by unit price. So when extended price is determined by quantity and unit price, quantity and unit price determines extended price. And that's what the functional dependency means. The dependency means the social security number determines somebody's name. There is a one-to-one relationship between social security number and a person's name. A social security number, a driver's license determines a person's name. A address, so if something determines something else, then we say it is a functionally dependent. Like the student ID determines student name, student attribute on the left-hand side is called the determinant. Student ID is the determinant which determines student name. Like the example I gave, social security number determines the name of the person. The passport number might determine the name of the person. The name of a building and the city it is in, like the Empire State Building, New York, might determine the address of where the building is physically located. The So we will look into functional dependencies, and I'm getting to, as we get more into the class, we will talk about why functional dependencies are important, but we are just introducing the concept of, so we are in slide C16. If you're unable to follow it, you can, you can certainly download the slides and follow it that way. Following object color. Like if we have a table which has object color, weight, and set, you can have dependency that object color is when we don't want to. If you knew that all yellow balls or all are 7 pound weight, then you can say object color determines weight, because all red balls are 5 pound, all blue balls are 5 pound here, but it can be 6 pounds, and all yellow balls are 7 pounds. So when you see the color of a ball, you can, from this table, you can say the weight. So object color is determining the weight. Similarly, the object color is determining, and I think this is a bad example. Let's say the red is red color, the object color is a red ball, cube, and the other one says a triangle. So you can say object color is determining the set. So all yellow things are cubes or triangles, whatever. So that's what the determination is. You are saying that object color determines set, object color determines if it determines weight and set. So again, don't get into too much details into this particular example, but the idea is, if you can look at the color of something and you say, I know the weight of something. So if you have all red balls and the balls are 3 pounds, so you can say, oh, I have a red ball, that means it's 3 pounds. If I knew that all the red things are balls, then you can look at the red color and you know those are balls. So they're determining the set. If we knew that by looking at the color, we can find the weight and set, then the color determines the weight and set. A determinant of a functional dependency that consists of more than one attribute. Like we said, if we look at a color of a student name and a class name, because we know that grades are associated with a student for a particular class. So if there are, for a student name, for a given student name and a given class name, for a student X, can see as 3730 for a particular unit. Like this is assuming that there is only one CIS 37 being offered. So let's assume there is only one 3737, and that's offered in summer. For summer, student name and class name means a grade. When you have more than one thing on the left-hand side, determinant that for a particular student, for a particular class, there is a particular grade. And that is for that is called a composite determinant. Okay, let's check with everybody. Some of you told me that you missed the first 15 minutes. So I can go through the slides, the first few slides relatively quickly. Let me see how many of you didn't hear me first 15 minutes, so that I can go through the first slides one more time. Who wants me to do that? Okay, so we have got enough people, so I'll just quickly go through the slides so that everybody feels comfortable. So let's. Okay, so this is the first slide that we really need to understand. The idea is that if you get a data from somewhere where, like we did the examples in last class, we have order item, school data, and school item, three tables you got. Should we, and the whole purpose of this chapter is, should we just store the data the way we got? What is the best way of organizing the data? Should there be one table? Should there be more than one table? Should there be three tables? Should there be five tables? How do we figure it out? What is the most efficient way of doing it? And that's what we are going to talk in this chapter. So before we talk about how do I organize my data into tables, what we are going to say is we need to learn a little bit about the relational model. The all organization of these tables is based upon something called a relational algebra or a relational model. So, so we are going to talk about a little bit about relational model. And the relational model is based upon, as you know, in 1970s, mainframe was the king. Everything was done by mainframe on big servers, and here there was every information was stored in terms of flat files, and it was mostly inefficient because in flat files you store the same information again and again and again, especially the repeating information that is part of the whole data. Like if you are storing information about a person and that person has, like in a church system, they have benefits, they have buildings that they're working, they have projects that they're working in, and it is, if you store all the information in one big honking spreadsheet or a flat file, you tend to repeat a lot of information which is not relevant. So the idea behind relational algebra is to store the information in such a way that we reduce the number of repetition of any information. So if the example is, if I say how many, I wanted to store information about somebody's children, instead of writing all the children like name of the parent, first name, father, mother, and name of the child, then again I go in the next row, I write father, mother, name of the child, father, mother, name of the child. If they have 7 children, then I wrote 7 times. So what is the best way of doing that without writing it 7 times? Or if what happens if a couple has an 8th child, now it's very difficult to go back and update these things. So relational algebra is basically to get rid of storing information that is duplicate. So here Ford, who was the IBM engineer, came up with this new way of storing data, and that's based upon the relational model that we're talking about. The relational model consists of these key terms. So all of you must understand what all these key terms are. We're going to go through them one by one so that you understand it. In the next class, we're going to talk about how you can take a set of information or data and organize it in such a way that it is the most efficient way. So the project that I have asked you to do, that's what the ultimate result will be. When you are taking a very big concept, you come up from that, I'm going to do a Amazon kind of retail online outlet, a database to support. Then, as I said, that is the project outline that I'm looking for. From that, you should be able to say, okay, I'm going to do an Amazon kind of database to sell stuff. Then what those should have? They should have information about products. They should have information about customers. They should have information about billing. They should have information about shipping. They should have information about competitors. They should have information about likes, dislikes, customer review. So you can come up with at least 10, 15 things as I'm talking about. And those are all entities. And this is the project. I'm looking for at least 8 to 10 entities for each project that you were talking about. An entity is something that user wants to track: customers, computer, sales, like remember the Amazon example I was giving. This is it. I cannot make it more concrete than that. When you are looking to, and let me repeat, I think if you understand that basic concept, that everything that we are going to talk about in this class is as simple as making a very simple classified version of Amazon, if you understand that. I have to track things that I am selling. I have to have product information, I have to have customer information, I have to have shipping information, I have to have, and each one is an entity. Within shipping, there is a lot of information. I have to have address. I have to verify whether the address that the customer has entered is a valid address. I have to have shippers. I have information about UPS, FedEx, other shipping methodology. The cost, depending upon the size of the thing, the weight, size. So you can think of, so when you think of problems like this, then you can think of that, okay, eventually I want to store all this information in distinct places. I should be able to pull that information and give the end user, go today to Amazon, try to pretend you are buying something. You'll see all the things that come up. Just pay attention. When you type in that I'm looking for a iPhone, what exactly happens? Or I'm looking for a best deal on a phone, or I'm looking for buying some cooking stuff. And just follow through the steps that Amazon does to get you and see what exactly is happening, where those data are coming from. If you just think through it for 15 minutes, you'll get the whole reason why we're doing a database management and why it is important. Okay, and I think that's the way we were talking about. We were talking about relationships, relations, and I think you all got this. Okay, so we got this, functional dependency, I think you got that. All right, good. Okay, so it's 8:40. We'll take a 15 minutes break. We'll come back at 8:55. We'll go through 9:20, 9:30, whatever. And okay, before we go, let me do a couple of things. I got email from one or two people, and I wanted to address it in the class itself, then individual email. One person said, I think it is Kisan, who said that he thinks all his group members or two of his group members have dropped the class. So I will encourage you to join another group if there is, I think it's too much work for one person to do. I will encourage you to find another group which is like 3 to 4 members and join that. Is anybody else who has group members? Okay. Does anybody else who does not have a group, who feel like lost? Anyone else? Okay, good. So we have Kishan group. Anybody else has a group? Okay. Anybody has any other question? I think I should give you enough time. I personally understand the frustration of online class. But it is what it is, and there is a little I can do to make it better. But on the other hand, if you have any other question, let me know. I'll be waiting for your questions. Anybody's email I didn't respond. You asked me a question, I didn't respond. I'm sorry, sometimes it's a little delayed. As I have told you earlier, I am extremely busy. I have lots of other engagements, but I make sure that anything that is important is okay. I am going to, when I give you the quiz, I'll go through everybody, and I will come to the chat room and will tell whom, the project plans, the project proposals that I received. Anybody has any other concern, that I'll tell you tonight. And please let me know if you're unable to hear or see the slide, especially seeing the slide, because if nobody is able to see it, let me know as soon as you don't see it, so that I have no way to know whether you're seeing it or not, because I don't see your screen. Anybody has any other questions? Anybody's email I didn't return that needs an answer? Okay. So, yes, I'm going to confirm anybody's project that any email I received in as soon as I give the quiz, and I will do it tonight. Okay, so we'll take a break. We'll be back at close to 9 o'clock, and we'll go as long as we can, and then we'll start doing the quiz. And again, quiz, I'll email you the quiz. You can upload it to quiz 1 under Dropbox in Desire to Learn. If you have problem with it, send an email as long as it's stamped the right time. I really don't care. All right, thank you.